Okay, so today we're going to be looking at what a function is, and a function is basically just something that takes an input and gives you an output. So for example, we'll have some function of x, because that's one way we can write it, is to do x plus 2. So it's going to take your x value and then it's going to add 2 and it's going to give you out f of x, or y in this case. You could have written it y equals x plus 2. You could also write it as f turns x into x plus 2, something like that. Lots of different ways you can write it. All of them are perfectly fine. You can use any letter you like. We usually use F, but you can also use G and you can use H. They're the ones we traditionally stick with. Next thing we're going to look at though is exactly how functions work. So we've got two types of function. You've got one that maps things directly to other things. So for example, if I were to give you, we'll stick with x plus 2, if I put in a value, it's going to give me 0 plus 2, which is 2. If I put in another value, 3 plus 2 gives me 5. If I put in minus 3, it will give me minus 1. All of those values will give me one individual value out. It is a 1 to 1 function. A function that's not so 1 to 1 is something along the lines of this. If we had our function is x squared, then we could take our 0 and it would give us 0, and we could take our 3 and it would give us 9. But if we take minus 3, it will also give us 9. Okay, we call this one a many to 1 function, because it means that an input, more than one input, sorry, can give you the same output in this case. So your two choices are 1 to 1 functions or many to 1 functions, and it's worth remembering the difference between those. So now would be a good time to note that down. The next thing we're going to look at is the domain of a function. Okay, the domain of a function is the set of input values that you can use that will actually work for the function. So for example, if your function was y equals root x, that would work for everything from 0 upwards. You could put in 0 and you'd get 0, you could put in 1 and you'd get 1, but if you put in negative numbers, it doesn't work. So putting in a negative number into this will not give you a real solution. So we would say that our domain is, it works for x has to be greater than or equal to 0. Okay, for all of those, so that's our domain. So to define a function, what you need is you need the rule, which is how you calculate it. So for example, our rule would be y equals root x, or we could write f of x is root x, something along those lines. And we would then also need to give it a domain. So we would say x has to be greater than or equal to 0. So that would define our function. So you need a rule and you need a domain as well. Right, so the other things that we need to look at are different things that you can use to explain your domain and so on. So we're going to look at this funny little symbol. That means x belongs to the set of real numbers. So that's all rational and irrational numbers. For those of you doing further maths, it means not complex numbers. So the set of real numbers is everything that's rational and irrational. Anything that you can write as an actual number. So you could, for example, you could do, if your function, do f of t this time just to be different, is 1 over t minus 2, then you could say it works for t belongs to the real numbers, so any real number will work except for 2. Because if we put in 2 here, you will get 2 minus 2, which is 0, and we can't divide by 0 because it wouldn't give us a value, it would give us infinity, and that doesn't help anybody. So you can use these symbols to help define your domain and your range when we get to that one. So x belongs to the set of real numbers, and you can also exclude things as well. So for example, if we had some kind of function, let's go with f of x is x squared, so that would look something like that. But we said that in terms of our domain, because we've got our rule, in terms of our domain, if we said that x had to be greater than or equal to -2, then we would have to rewrite this graph so that it looks a little bit more like this. We would find -2, and because it's an equal to, we are going to use a coloured in dot, little coloured in circle, and it works for everything above, so we can carry on with that. But this stuff has disappeared because we don't care about the bits below -2 anymore. We've been told that our rule is only important in this domain. So we use a coloured in circle for includes the value, and we use that for not included, very much like inequalities. Okay, same sort of thing. So the range of your function is the set of possible output values. So you've got the range, set of possible output values. And instead of being just on a number line, as you would have drawn it in inequalities, we would show them drawn on a graph like this. So this would be your solution. This would show the range of this function. Okay, so that's how you would show the range of your function. So what we're going to do is go through a couple of practice questions and check that we've got our heads around exactly what's going on. So we are going to start with, let's go with f of x is x squared plus 1 for the domain x has to be less than 1. So what we're going to do is we are going to show exactly how we can show the range, how we can sketch it, and we're going to have a look at what happens if we change the domain. So if I were to sketch that one, I want x has to be less than 1. Oh, not -1, 1. So we want x squared plus 1. Now we know from core 2 that when we add that, that's changing the y value. So it's x squared plus 1, it's going to be what we had before, only moved up a little bit because we've added 1, and it's going to go to there. And because it's less than, we're going to have our empty circle because this value is not included because it's only less than 1, it's not less than or equal to. Okay, so that's our f of x. If we then look at g of x, and we make that x squared plus 1, but we make it for x has to be greater than 1, then that would look a little something like this. So again, we want our value of 1, and we want to look at where x is greater than 1. So we know that our curve would go like that, but we're only looking for this part this time. So we've got that. Now we can look at those and we can say from that whether our graph is a one-to-one or whether it's a many-to-one. And the really, really simple way to do that is to take something that's a straight line, so for argument's sake I'll say a pen, and if I run it through here, if I can make it go through the graph at more than one place, then it's many-to-one, because that tells me that both those values, here and here, are going to give me the same solution for y. They're going to give me the same output. So that would be a many-to-one graph. Whereas this one, if you go through, it will only ever cross at one place, so that would be a one-to-one function. Okay, so that's the difference between the two. Other one that we're going to look at is we're going to try and figure out the range of this one. So if you've got h of x is 1 minus x squared, and x has to belong to the real numbers, then we're going to draw ourselves a little graph and see what we come up with. Let's sketch ourselves some axes, x and y, and then we've got, it's a negative x squared value, so we already know that our parabola is going to be upside down, and we've got a translation of 1, which means it's going to be going through up here instead. So we've not got any particular restrictions in terms of our domain, so we just sketch the graph as we normally would. And we would say that our range is therefore h of x has got to be, bearing in mind we went through 1 here, h of x has got to be less than or equal to 1, because all of our values for y are going to be less than or equal to 1. None of them are going to be above. So that would be the range of our function.